How are we doing today? Is this not the best technology conference you've ever been to? And it just keeps getting better. It's incredible. Delighted to be here today to talk on this incredible topic. I had the pleasure of writing a book with Doug Jamison, who you listened to earlier this morning, it was called Venture Investing in Science. It was published by Columbia University Publishing. In June, we had the pleasure of having Mark write the foreword to the book. And we talk about some of the key issues in venture investing and what's going on. And as we were writing the book, our publisher at Columbia said, so there's a lot going on in software, Steve, but where are the other opportunities in science? And I said, well, there's a ton of opportunity in materials. There's a ton of opportunity in obviously in health that we talk a lot about here. But I wrote a segment about 3D printing, graphene, advanced materials. And the more research I've done since we published the book, I'm absolutely convinced. Mark and I met in the mid-'90s around the time that Netscape was being launched, and Larry Smarr's student actually was the CEO of Netscape, which is phenomenal, Mark Andreessen. And I remember when Mark Anderson and I met, we just had this Vulcan mind meld that the internet was a game changer, right? And I remember Mark telling me, he's like, my test for whether or not I invest in a company is if the CEO has a computer on his desk. This was in the mid-'90s, right? And a lot of CEOs didn't have a computer on their desk. Mark, I don't know if you remember that, but that's the way Mark Anderson looks at the world, and I love it, right? And I was on Wall Street managing a lot of money, and I just resonated with that. So we had our Netscape moment, and it took, SNS was way ahead as usual. And it took Merrill Lynch, where I used to work, about 4 years to wake up to the dot-com, and as soon as they did, we had a bubble. And we know what happened. But Mother Merrill got involved, and the next thing, we had thousands of companies coming public, and it just got crazy. And venture capital went ballistic, and you can look at all the data in the book. But what's exciting today, and I've been working with a couple of these guys, Trevor and Shane in particular, and I've had the pleasure of meeting Phil while we're here at this event. But what's exciting to me is I think that we are having our Netscape moment in 3D printing right now, okay? And to me, this is terribly exciting. And Mark, when we did our Graphene Stakeholders Association event in Oakland in 2015, Mark opened up our event in Oakland with the Trifecta. And the last piece is 3D printing. And so Mark and I have been pounding the table on 3D printing for years. We are now today, and we're going to talk about this with these fine gentlemen, we are now today at the Netscape moment where we're going to go exponential. We've heard a lot of technology grows exponentially. It's just the way it is. Humans think linearly, and technology grows exponentially, and that's where it gets interesting. But if I'm going to ask each of my panelists here whether or not we are having a Netscape moment in 3D printing, and if we are, what are the implications of that? And I think we can have a very engaging discussion. We could probably talk for hours about this, but we've got about 25 minutes. So we've got estimates of 3D printing. Additive manufacturing is the buzzword. We're going to talk a little bit about the other terminology. But I've seen the Wohlers report came out and estimating $20 billion of additive manufacturing activity by 2020. And I saw a report by McKinsey saying that within the next 5 years after that, if we're looking at 2025, $100 to $250 billion of additive manufacturing activity. So that's our dot-com curve. So everything in manufacturing is about to change drastically. And we need to think about this very seriously, how it's going to impact our businesses and our industries. So GE is launching a printer called Atlas. We're going to be able to print aluminum, I think, for the first time ever. We're printing metals today. There's hundreds of materials, maybe 1,000 materials that we're able to print today. So we're going to want to talk about all the innovation that's going to happen and how the industrial landscape is going to shift and how that plays into the carbon trifecta. So, Phil, I think I'm going to lead with you because you've launched a new company, Titomic, and you are going to be out on the cutting edge of 3D printing in metals. So tell us about your vision for Titomics and how you see things evolving over the next couple of years.
Yeah, Titomic is an additive manufacturing company that is quite young. Its angle is a new type of physics around bonding metals and ceramics. And all existing 3D printers for metal have used lasers to fuse metal powders or electron beams, basically melting metal. Melting metal, I'm just going to take 60 seconds to talk about the physics.
Sure.
Melting metal means heat. Heat, when you're working with metals, means oxidation. Oxidation means inert atmospheres in a can, and it means small, because when you put a can with inert atmosphere in, it means not big. It also means warpage, because you put powder down, you hit it with a laser, you melt it, you put more powder down, you hit it with a laser, this super hot, this one's cooling down, and it gets hot and cold all the way up, and which means the parts twist and warp, which is a real problem, and that limits speed. Now, Titomic is built on a new type of physics around kinetic fusion, so we actually can bond metals and ceramics cold, without temperature. That means we're not constrained by any of that. You want a 100-metre long part, what's that in imperials, 100 yards, roughly speaking, long, no problem. You want something that, and it also means that we can build huge amounts of volume. So our first step is 45 kilos an hour per nozzle. Now that mightn't sound like a big number, but in relationship to existing printers, it's nearly an order of magnitude faster, and it's an order of magnitude faster than most things that most people use. And that's, so we think we're the first in an industrial scale additive manufacturing. Now there's something else that's really important. When you bond materials cold, we can make materials that were never possible to make before. So I've held in my hand an alloy that is a metal ceramic alloy that has about the similar properties to titanium, but it doesn't smash when you hit it, so it's more malleable. It doesn't shrink or expand when it's heated or cooled, and it's been tested to maintain those properties up to 3,500 degrees Celsius, which was the hottest lab that could be found to do the testing. The physics tells us it'll go to 5,500 degrees Celsius, which is nearly the surface temperature of the sun. So when we think about new materials like that, it's not just about reaching industrial scale, it's about redefining the way we design and manufacture every new product. Instead of saying, these are the products, these are the materials we can use, engineers can say, these are the properties we want, and we can start engineering the future and at scale.
Right, and so Trevor, you've coined a term, functional intensity, and I think that plays right into what Philip was talking about. So tell us about functional intensity and how it plays into 3D printing going forward.
Well, we touched a bit on this yesterday when we were looking at Haydale Technologies as a fire starter. Functional intensity, to coin the phrase, is really about getting more from less. We've heard a lot about the fact that we're depleting our resources. We've got an energy crisis, dare I say. The impact on global climate change is indisputable. So we have to use less, but get more out of it. Customers' expectations are for better performance, longer life, stronger things. So the traditional definition of value of function over cost is still embraced. But I think now what we've got to look at is function per unit of volume, function per unit of mass. And the three of those, as well as function over cost or value, is what I call functional intensity. Now, we've been pushing forward on that for a long time, but I really think what we're already hearing from Phil and what we'll hear from Shane shortly is exactly as you said. It's the inflection point where additive manufacturing, particularly with metals, is going to see us transform from still good value metals to incredibly functionally intense metals, but manufactured on scales we couldn't do before and at costs we couldn't do before, because the materials we have to use are expensive and you can't disperse them through an entire part and make it affordable. But the ability that the additive manufacturing tools offer us today of selectively adding high-tech materials into parts is going to make them affordable and make all elements of functional intensity achievable.
So when you think about what's happening, and you go up from a big picture perspective, I think what we're seeing is the convergence of atoms and bits, and maybe down the road atoms and qubits. But we've been in a venture investing environment that is focused pretty much on software. The materials companies that I've collaborated with over the years are having a very difficult time raising capital. But if I come in with an Uber-like business plan, boom, I'm there. So the materials guys traditionally have had difficulty getting attention from Silicon Valley and other venture capitalists. But what we have to do today is realize that materials themselves are becoming technology. So we could call it MATEC, as you say. But
I think you coined that phrase, actually.
well, maybe we both did. So, or we can credit Ray Gibbs. So we've got this convergence going on. And Shane, when we started talking, when you first started talking to us about Link 3D about a year ago at the SNS dinner in New York last December, and you started talking about your vision for what you wanted to do, I was jumping up and down. Like, this is incredible, right? And now we've had almost a year of progress. You've launched some big software. You've talked about it on the stage. But the convergence, Link 3D is going to be the glue that brings all of this together and brings this convergence together. I think capital is going to flow increasingly into materials now, and we're seeing that. You just did a public offering, right?
Yes.
Haydale is public. We're going to start to see increasing investor interest in materials, and your software is going to bring it all together and totally transform the manufacturing landscape. So tell us about this transformation and the role that software is playing.
Yeah. You know, it's interesting. I wrote that SNS newsletter last week or 2 weeks ago. If anyone read it, you know, we talked about the dynamic shift in engineering. And, you know, I think someone had just mentioned it, that you used to have to design around material constraints. But now, you know, meteorologists are actually leading the initial design. So it's not, you know, we could do nickel alloy, titanium, this, that, or the other thing. But what we're seeing is meteorologists developing, you know, super alloys or new polymers or, you know, carbon-based products. And that's, you know, really interesting because it allows design without boundaries, right? And just to you know, talk a little bit about the impact that, you know, we as humans are having on the earth and in some ways destroying it. You know, I stumbled across 3D printing years ago and fell in love with it. And, you know, I've learned, you know, I'm young, but I've learned that, you know, a young person can have a huge impact on the globe. And, you know, I decided to go down the route of 3D printing because of the sustainability factors. You know, it's great to design amazing parts and it's great to produce mass volumes of parts and all of that. But when you look at the recyclability of the materials, you know, industrial grade 3D printing today, you can recycle almost 99% of the polymers or metals that come out of the machine. Another amazing thing is low volume batch production. You know, these guys are focused on big scale production because this machine's insanely amazing. We focus on, you know, the little bits and the bops that go, you know, in the fuel nozzles in the airplanes, or, you know, the knee replacements in your body, or rotors inside of cars. And when you look at the rate of obsolescence in technology, it's crazy, right? I mean, especially in additive. So one thing Link does and we promote is like the digitization of all of your parts, right? Or at least the parts that are qualified for additive. Because if you can reduce your physical inventory and adopt low volume batch manufacturing, you know, one, your company's bottom line is going to increase, but two, it's a wonderful thing for our environment. And also, you know, one other thing we focus on is true on-demand distributed manufacturing, right? So, you know, if you're an orthopedic company and your distribution is in Holland, but you're in Seattle and you're building parts and you're shipping them, whether it be freight, air, whatever, CO2s, gas, fossil fuels, the whole 9 yards, you're having an impact. And, you know, manufacturing is a $10 trillion industry. Everything gets made. So what we try to do is encourage our customers to adopt low volume batch customized manufacturing to reduce their physical inventory, to mitigate the obsolescence rate, and also improve their logistical costs. You know, you improve the logistical costs, great, but you know you're really doing great things for the environment.
So Phil, do you want to comment on that?
Yeah, I think you mentioned about the I was going to say Netflix moment, but Netscape moment. Yes.
Well, there was a Netflix moment too. Yes.
Yes. The Netscape moment, and for me that implies a lot of people getting involved and using it.
Yeah.
And what I think we're at the moment is a combination of what the two of us, what we're all doing here.
That's right.
Existing industry is hugely bigger than the additive manufacturing industry today.
Yes.
And companies like Titomic can serve existing industry now. So we don't have to wait to build scale. We can start delivering scale now. We can start transforming industrial process that reach billions of people. And at the same time, we can start engaging with you know, millions of people doing distributed work around small numbers of parts. And that's an interesting perspective because it means that we're at the moment where we can affect change in both areas, which means we can engage potentially all products.
Right. I want to drill down a little bit. I grew up in Michigan, and the automobile industry when I back in the 70s, 60s, and 70s, basically Saginaw on down to Detroit, produced the steel in Saginaw and go and have an assembled car in Detroit. Trevor spent 30 years in the automobile industry. We're talking about titanium. We're talking about printing aluminum. If you're an auto guy, right, and Shane comes in and says, I've got software that can, you know, basically re-engineer your whole process, your industrial process, right? And you're an auto executive. You're sitting there at Ford or GM, and your head's starting to spin, right? Because you can now start to create materials that you couldn't manufacture a car with before that have certain functional intensity, right? And offer and start to innovate in a way you could have never innovated before, right? And I know innovation is an overused word, but in the case of 3D printing, I think that's exactly what it's going to foster going forward. So how does an auto executive and a materials guru think about, you know, how to harness this and really accelerate it to get, you know, new products out on the market?
That's a huge question, Steve.
Well, that's what we ask here. Right. We ask big questions here.
I think it's very interesting for the automotive world because I think it's going to be, overused word, transformational. There's really two parts to the automotive business. One is the regulatory side of it, to which you can't make frequent change because of the recertification cost. Mm-hmm. But we all know that one of the big things, one of the big drivers of car sales is change. A new model comes out, a new technology is added into it. Traditionally in the automotive industry, the tooling cost for doing that, be it a body style, be it whatever, has been huge. Right. And with more customization and smaller volumes, you have to run a product for a long time to get a return on that big investment on the tooling. Yeah. Unless I'm mistaken, there is no tooling bill with additive manufacturing. You go straight from the bits to the atoms, right? Yeah. So now you have the ability to change much more frequently. you can, if you 3D print parts of the vehicle which aren't subject to certification, right?
Right.
You can actually change them very quickly. You can even get into mass customization.
Right.
Because you could have someone sitting with a designer saying, no, I actually would like that to look a little different.
Right.
Yeah.
Pens it up, print it straight away,
Right.
and there's your car.
Exactly.
Exactly as you want it.
So you go ahead, because I don't know if you've been, how many trips you've made to Michigan to talk to these guys, but I'm sure you have.
I have.
And I know there's probably things you can't tell us unless you kill us, but tell
No.
us what you can tell us.
No, actually, so to dovetail off what Trevor was saying, so my last startup, we were working with Audi, and I don't know if the I
There
don't
go
know
the
if the
profits.
portal. Yeah, I don't know if the portal's out, but you can actually go inside Audi and customize the entire interior of your car. So basically, anything that's polymer based, you can customize it, you can optimize it. It 3D prints and it's put into your car. I don't know if it's out yet, but that was a project we were working on, mass customization.
Yeah. Mass customization. Phil, what's your thought on mass customization?
Well, I think there's several elements to that. Working with polymers is one thing. Working with metals is something else.
Okay.
And customization means different things to different people. One of the things I didn't mention before was that the Titomic machines will not be machines by themselves. We're actually building finishing cells as well. So effectively, we're delivering full production lines. So as an example, we're working with bicycle manufacturers at the moment, and we're producing from nothing to a finished, polished part ready to start bolting things onto for the frames. So we're taking care of the entire process. And that makes it possible to start finishing the customization, not just starting it. We can conclude the process. There's another important point here in terms of the automotive industry. The automotive industry is going through change, and electricity and battery powers is an issue. So one of the big things we see is that because we can work with materials in a different way, as one example of that, while we can print many different metals, I'm going to use titanium as one example. The compressive yield strength that we can print straight off the nozzle is 34% higher than the best aerospace grade stuff you can buy today.
Wow.
Now, and we can manipulate the parameters for different purposes, but weight is going to become a big factor in cars because weight means range. Weight means lightweight means smaller batteries for a greater range. So when I think about the future of the industry, I think about it in those terms.
Okay.
To me, the customization from a sales perspective is important, as it always has been.
Right.
I want to buy that one because it's pretty. I want to buy that one because it's got an interior. But in terms of what wins in the long run, it's still got to be better. It's still got to deliver a greater overall benefit. And to me, weight and performance is still going to be the key.
Right.
Because when we shift to batteries, it means less batteries, less weight, more range.
Right. Well, that's functional intensity, right?
Yes, it is.
There we go.
And one other thing I'll say is if
Sure.
you look at the GE new Leap engine and you look at the fuel nozzle, they took 120 parts down to one part, titanium based. I mean, it's it's about customization for the sales perspective, but I 100% agree.
I heard from GE, which just moved to Boston, but they used to be down the street from me in Fairfield, Connecticut. But I heard when they brought the part to the chief, and he said, you've got to be kidding me. We can do this, right? And really, 80% of the cost with more functionality, this is a no-brainer for GE. And GE now has a division, right? It's, a year old, 2 years old?
Year and a half.
And they're investing billions of dollars in GE additive, right? You went and saw them earlier this year. You're probably talking to them right now. So think about that. Somebody brings you a part, re-engineered part, it's printed, it's 80% of the cost, and it's much, much better, right? So that's what we have, that's the economic opportunity. I think we're going to see a lot more investing in the materials side. We need that because we're going to have an explosion of innovation in materials and different technologies that fall right into what Shane's doing. So we have a question here. Let's take that. We've got about 4 minutes to go.
Just the first time one of these printed pieces of materials fails, we're going to have an industry in panic about what's going on. So my question is, what about certification and validation of the actual quality of the material that is consistent throughout, that we've actually certified the processes so that you still have the same material strength and strain and all the other performance curves of the
Right.
materials?
Great.
And then things like the FAA, let's say you have a distant outpost and you can manufacture out there, but how do you actually guarantee that the FAA, that's an FAA certified part that you've manufactured? Because whether it be an FAA part or a cyclist going downhill at 50 miles an hour, the last thing you want to do is fail.
Yeah.
Great question. Who wants to take that?
I can answer the second part.
Okay.
Phil can probably take the first part. So in regards to the validation, so what happens is once a design has been approved by the FDA, FAA, whatever it may be, whatever government regulatory body or whatever, you essentially have a digital file that's locked down. It's called a build process file. Now this file, if you're using our software, we can encrypt it for you, or you can use anyone else's software that's in our space. And what it does is it encrypts and locks down that file. And then on the machines, if you look at a DMLS EOS M400, that machine is calibrated and locked down as well. So what they do is before these parts are printed, there's hundreds of types of prototypes, especially inner body, things that go in the sky, space. And what they do is they lock down the parameter sets. They calibrate the lasers, and they check for consistency throughout the build. And one thing we do is we offer full traceability. So what we do is we take the part, we attach a traceability report to it, and then there's a build report. It's 2.5 million lines of code. We scrape it, and we auto-populate the traceability report. So basically, you can look, right, and see all the knowns versus unknowns. You could see, the variances, if need be, for recalls or what have you. So the processes are being put in place. I mean, there's 2 million orthopedics in people's bodies today. There's planes flying around with 3D printed parts. It still needs to get better, and that's what we're trying to enhance. But that's somewhat of the process.
Can we build certification right into your software? Can we foster that through? I mean, have you thought about that?
No, we don't want it. We don't want
You
that
don't want to get
liability.
involved?
No.
Phil, any thoughts about that?
Yeah, we're building sensors into our systems so that we can monitor what's going on at a lot of levels. We're also having a research back end as well, so that we can actually get ahead of the curve and understand the statistics that can help drive future standards.
Yeah.
Because we're really going to places, and we're working with folks at government level to help them write policy at the moment. And so we're trying to get ahead of that issue rather than respond to it.
Okay. If there are any other questions, feel free. We've got about a minute left, and if we don't, do we have a question? Go ahead.
Sure. I'm just curious on the whole 3D printing, if it's being used at all in furniture production, because I think about, ordering a bunch of furniture, which right now, companies don't even carry an inventory.
Yeah,
so it's so much of it is being built to order, and it seems like a great opportunity to incorporate design and.
Go to IKEA. IKEA has 3D printed furniture already.
Whether it's lots of little printers around the world or big industrial printers, we're really talking about converting software into hard products. And so even at an industrial scale, the ability for industrial players to produce products uniquely for each customer, that's where both sides are going.
Right. So we're talking about precision medicine. Now we have precision manufacturing, which is fantastic. Yes, sir.
It's easy to see that additive manufacturing, 3D printing is an exponential technology, but we've talked about in the past. Bob Gelati from Deloitte was saying that manufacturing is kind of in the lower left quadrant, that kind of the 2x revenue. Is this technology really going to get manufacturing onto a higher multiple, higher profitability? Maybe it's linear. Is it going to go from 7% profit to 9%? Or can we really get these stocks ramping up from additive manufacturing?
That's the fundamental proposition. It's an economic proposition. It can't just be about some beautiful vision of the future. Where we're taking things is to recalibrate the economics of manufacturing. So from a Titomic perspective, we don't see our competitors as other additive manufacturing companies. Our competitors are every other industrial process.
Okay, Trevor, do you want to just we got to finish it up here, but last comment?
I have a
Okay.
comment.
Great.
We get a lot of opportunity and a lot of exposure for our companies, but I don't think everyone knows all of your background, Steve. You talked about managing money on Wall Street. You did a lot of incredible things. Then you got hit with a health scare. You came through it.
Yeah.
It changed your life.
Yeah.
And since then, you've devoted selflessly a lot of time, effort, and energy to promoting startup and early stage and growth companies. I don't think you get the recognition. We get the recognition for our companies.
Thank you.
You don't. So
Thank
I want to
you.
say a personal thank you to
Thank
Steve
you.
for
Thank
everything
you.
he does.
Thank you. Thank you all. Have a great event and enjoy every nanosecond of it.